Hey friends, this is Quest and Current, and today we're going to take a look at this USB-C based lithium battery charging and discharging module with included battery protection to save your battery from being discharged too much. It features this charging IC which with its two accompanying LEDs, a red and a blue one as far as I know, for indicating that it is charging and fully charged, as well as the battery charging circuitry with this double MOSFET in one package and the battery discharge and overcharge IC. And we are going to see that this USB-C based module actually only works with a USB-A to C cable and not with a USB-C to C cable, even though both of them are perfectly fine and in working order. And we are going to take a look at why that is and take a look at the early versions of this module to understand how it came to this point. But before that, I'm going to show you how it actually works. So I'm going to take this USB-A to USB-C cable with my power bank, which features both USB-A and USB-C outputs. And if we use a USB-A output and turn on the power bank, then we can connect this module and we can see that it immediately lights up. The blue LED is fully lit and the red LED is blinking. This is due to the fact that we are not actually having anything connected to the output. So it will always try to charge the output a bit and then indicate that it's fully charged. So it is working as intended, but if we unplug it and try the USB-C to USB-C cable and turn on the battery again, the power bank again, really sorry, we can see that nothing actually happens. So it's not working even though the power bank is turned on and fully operational, nothing happens. And the reason for this is actually within the USB-C standard. So USB-C to USB-C cables do need to feature a special pin, actually two of them, the CC1 and CC2 pins, where they can agree or negotiate the power supply with the load. What kind of current do we need? What kind of voltages do we need? And the easiest way to implement this is to have two 5K1, 5100 ohm resistors on the load side, pulling both pins CC1 and CC2 down to ground. And we can take a look at any kind of USB-C connector layout, and we can see here that CC1 and CC2 are on the connector here, and they even say that it's a configuration channel for plug orientation, roll detection, current mode, and USB power delivery communication, as well as the WCON in case of an active negotiation. So one of those two, and actually on the load side, both of them need to be connected to ground with a 5.1 kilo ohm resistor for them to actually work, and for the power supply to start delivering a voltage, to start apply a voltage, and to start delivering a current with that. And now you may ask, I mean, this is a really nice module. Someone has put a lot of thought in it, especially with the battery protection circuitry. Why can't we use it with a regular USB-C to USB-C cable? And for this we need to take a look backwards again to all the cables like the USB-A plugs. We can see that this plug, for example, only features 4 pins, and the USB-C plug on the other hand features 25 pins. If we take a look inside, we can see that all of them are actually populated, but the cable itself only has 2. It's just the VBus, the voltage, the 5 volts, and ground. That's it. Nothing more, nothing less. And to indicate that this cable is the charging end of a cable, so if I connect my phone to my laptop or my charger, this connector itself needs to advertise itself as a charging connector. So this connector needs to tell the device that it's connected to, hey, you can charge from this end of the connector. And this is where the power source, the downstream facing port, comes in. So this means that there are actually resistors inside the cable that indicate not only from the receiving end, but also from the supplying end that this is a power source. And if you connect it, you can see that this cable actually advertises itself as a power source. And the connections are only VCC, the VBus, and the ground being made. There's not even a shield included in the cable or special pins for the USB 3.1 standard that would be needed. And now that we know why that is, we can go back in time and explore why this happened. Why did they miss to actually build this according to standard? Why can I buy this so cheaply? Because it's not actually working as expected with all the cables that I would expect it to work with. And for this, we go back one step and take a look at this module. Besides being slightly darker blue, there's one key difference, the connector. This older module still has a micro USB connector, and by taking a closer look at both of them, we can see that the rest is basically identical. So the older one has slightly bigger components, the LEDs are slightly bigger, the resistors and capacitors as well, but with the new one they basically just moved everything to the right by a couple of millimeters and shrunk everything down so it still fits, but that's it. So what they did is they replaced this micro USB connector with a USB-C connector without actually thinking about the implications. So they thought, okay, nowadays we use USB-C because that's what you do. So we are going to replace it. And then they missed the key part where you actually need the 5.1 kilo ohm pull down resistors on CC1 and CC2 to advertise this as a load. And this is the reason why the USB-C version of this charging module actually is cheaper than the micro USB version. Because with the micro USB there is no such need for any pull down resistors. You can just use any cable, because this end of a USB-C cable always is the receiving end. So this can always be expected to deliver power, to deliver at least 500 milliamps at 5 volts. And with this, you can use the cable in both directions, and therefore you need the resistors. Someone missed that in production, and that's why we have this weird in between of the old version and the new version that actually is working. And you know, sometimes you think, okay, maybe my design is wrong, maybe I did something horribly wrong, maybe it's something I did. It's actually the designer's fault. That's why USB-C is really complex, and having something to test it on and having something of a background with the standard is always useful. So if you have any questions or comments, just put them below and I will try to answer them. And thanks for watching.